Hey, it's Clay. Welcome to another video. This is going to be another update in my series where I transform this Hammond AO-29 organ amplifier into a Fender style guitar amp. I want to talk about point-to-point wiring and how I'm wiring up this circuit. So at this point I'm basically shooting for something pretty close to a Blackface AB763 Bandmaster type circuit with some modifications. I don't have any reverb or tremolo, just a single input jack. Here's my V1 tube, tone stack, and I do have a lift switch, which I'll get into in a second. Phase inverter right in here, and then two power tubes which I've yet to wire up, and then the power section will be over here. But let's talk a little bit about some of the design principles with a point-to-point hand-wired amp. Now, with point-to-point wiring, I really enjoy it because it gives you a lot of freedom and flexibility with which to design your circuit. It's very easy to make modifications and tweaks, and overall I think it really helps with your understanding of how amps work. And you know, whereas if you're using a component board, it's more of a paint-by-numbers situation. There's nothing wrong with that. Some of the first builds that I did were with that style, and they're great. But point-to-point has really taught me a lot about how all this works. And so anyways, yeah, let's talk a little bit about design principles. So first thing and foremost is you want to keep your leads as short as possible, right? So I've got my input jack over here. I've got a 1 meg resistor going from hot to ground. Then this black is going to be this color of my signal wires. And I'm looping it over here a little bit and then running directly to this lug here when I've got a 68, or I think a 56K resistor going directly to my, I believe it's pin 2 of my V1 preamp tube. So want to keep that run as short as possible and direct as possible. In fact, it would be more ideal if I would have put the input jack like right here and just ran the resistor directly from the jack to the other side. But that's not how I chose to do this amp, but that certainly is what would have been perfectly optimal. Then you can see I've got a lot of circuit in here which is pretty close together, but it all actually came together really nicely. I'm just going to prop this up a little bit, see if we can get a little better light. So the main thing to keep in mind here is, so a 12X7 tube is basically it's a dual triode, meaning there's two gain stages, triodes. And the triode includes the grid, which is typically the input. Then you've got the plate, where the high voltage is fed and it draws the electrons. And then the opposite end is the cathode. Now in a typical gain stage, you bias the cathode, and then you have your high voltage on the plate, and then the audio, your audio signal flows from the grid, and then it's drawn up towards the plate and out that way. So that's basically what you have here. So the signal comes in. We've got our resistor here. That in a typical Fender, they have two jacks, so they run two 68K resistors from the input. And I've got a schematic right here, which I can show right here. So we've got two 68K resistors. Now I chose to use like a 56K resistor, just a single. Two 68Ks in parallel is about 33K. The exact value of this isn't incredibly important. I would say somewhere from 33 to 68K is probably pretty standard. Some amps don't actually even have, or they have a very low value. And basically what this does is it serves as a grid stopper. It works with the capacitance of the tube to roll off very, very high frequencies. So to prevent, like radio oscillations and stuff like that. I think at 68K, if I remember correctly, it's like a 15K hertz and above roll off, so that's fine. So I'm just using a little bit there, but you really don't need that. Just something to kind of help make sure that the super high frequencies aren't causing any sort of like parasitic oscillations, like things like above, in the radio frequency world, above 20K. So anyways, that comes into pin 2. Then to bias that, I've got it's way under here, but there's I believe I used a 4.7 UF capacitor and a 1.5K bias resistor. Now the bypass cap the value if you use a large, like 25 UF microfarad and higher. Basically, the entire spectrum of the signal is going to be allowed to bypass, and basically gets boosted. If you lower that value, then it becomes a low roll-off, a high-pass filter. And at about 4.7 microfarad, that's kind of where I like it. And that starts to get to, like, I don't know, between 50 and 100 hertz. And about 100 hertz and below is really parts of the signal that I don't really need, as far as a guitar player goes. So, the difference between a 25 UF and a 5 UF is really not a big deal. I would say if you want to make some design choices, you can use maybe a 1 UF or a .068 or 0.68. I think that's more of a Marshall style. And those values will really help to cause a much brighter, you're going to roll off a lot more low end. But I'm going for a little more of a balanced input here. Then I also used you can see this filter cap here. Now, what I chose to do, in a lot of builds, they'll group the filter caps over kind of in this area by the power section. But I chose to include my filter caps, and I got this from an article by Merlin Blenko on grounding. And this kind of is his local star ground type setup. And basically the idea is that the filter caps should be ideally grounded near the filters that they are filtering. So, I've got this filter cap, which is providing it's filtering the high tension B+, going on the plates. And this cap right here is filtering both of the triode stages in this tube. So it makes the most amount of sense to have it close by. So this yellow wire is supplying, I've got my step-down resistor, then we run through the cap, and then this middle lug here is my preamp ground. So every single ground in my preamp section of the amp is going to this connection point. And then this right here is my source of B+. So I've got a 100K resistor going to that plate, 100K resistor going to that plate for the dual triode. And then I've got another 4.7 UF bypass cap and 1.5K bias resistor, and that's for this second triode. So yeah, that covers basically everything that's going on here. Then I will also have to do the heaters. So yeah, the signal comes in. We've got the 100K plate resistor and the 1.5K plus the 5 UF bypass cap, which is kind of setting the tonality and the gain and the bias. It's running through this black wire over here, then running to the tone stack. And I basically just use typical Fender style tone stack values, right? So looking right in here, we've got a 100K slope resistor, 25 picofarad treble cap, 0.1 bass cap, and then I think I used a 0.02 mid cap, and then I'm using a mid pot. I used a 25K pot. It's this guy right here. So actually, if I put the pot all the way up, I have more mid-range than a typical blackface style amp would use. I think they typically had a 10K pot, if at all. And if if your blackface amp doesn't have a mid pot, I believe a 6.8K resistor is standard. So I have more mid-range capable, but I still can access that scooped sound if I put it down to about 3 or 4. And then the other modification I made is over here to the right. This guy, this is just a single pole double throw switch, and so this green wire here is this one. So right here. So this 6.8K resistor just goes straight to ground, and basically this ground point, the signal comes in and runs through all these filters, and this is the ground that bleeds. As they run through the filters, this is the ground that bleeds it all away. And so what I have here is the ground point comes to the middle lug of this switch, and then in the up position, it runs back here to my preamp ground, and then in the bottom position, there is no connection, which means that it lifts that ground point. So the tone stack has no ability to bleed these frequencies to ground, and everything is just allowed to pass. So it lifts the tone stack out of the circuit for more of a tweed voice. And it's a very, very simple modification to make. You just got to find either that 6.8K resistor, this one right here, either the 6.8K resistor that runs to ground or the pot and its ground connection, and then you put the switch in between. So that will allow me to have more of a tweed voice with a lot more gain. The tone stack introduces a ton of signal loss, so a lot more gain to be had. Which, yeah, so just with those preamp voicing choices, right? So the way you shape the values of the caps and I've got 250K pots, 25K mid pot, 250K treble bass, 1 meg volume, all of the component choices on this first triode that you make, all of those will really affect the voicing of the amp. And it just is an easy way to get the amp to sound and feel more like what you want, is just by playing with a lot of these values. So yeah, then our signal we've got right here, we go back out of the volume control to that second gain stage over here, which is biased, as I said before. Got a 0.02 coupling cap. And then I'm actually using this tube socket here as like a terminal strip, and then running the signal over here to our phase inverter. And I basically just used the stock blackface phase, it's a long tail pair phase inverter, and that's important. A long tail pair phase inverter has quite a bit more gain than some of the other choices, which is kind of essential, to, at least in my estimation, to getting, I think, almost all of the classic amps, vintage style amps that are non-master volume, that get that power tube distortion breakup. Almost all of them will feature this long tail phase inverter. And I think it's a pretty crucial part of the blackface Fender tone, crucial part of the Marshall tone, and just a really cool and good sounding phase inverter. Then I use quite a bit of 2 terminal strips, really, which is kind of a lot, because a lot of circuitry going on. Again, we've got a filter cap here, which is kind of the core. Again, we've got our ground point right here. So all the phase inverter grounds are going to be neutralized at this point. So, we've got a local star over here for the preamp, local star here for the phase inverter. And yeah, that kind of really covers the amp into these sections. And I still have room to insert another tube over here, just kind of move that wire out of the way, no problem. So yeah, again, trying to keep component leads as short as possible, trying to keep things as secure and solid as possible, and yeah, just proceeding forward with the build. If you have any questions about build techniques or anything like that, please let me know. I'm still kind of new at this, but I'm doing the best I can to make a good sounding and solid secure amplifier. But overall, I'm excited to see how this circuit progresses. Like I said before, I'm just going to go ahead with kind of this basic AB763 2 gain stage preamp, long tail phase inverter, and just kind of get it up and running and go from there. So hope you guys enjoyed the video, and we'll go see you in the next one. Thanks.